Hi. This was the lowest score in AP Calculus AP FRQ in 2025, an average score of only 3.26 out of 9 points. It's about an invasive plant taking over a fruit grove because apparently College Board has entered its agricultural horror era. You can pause the video right here so you can kind of read the question here, but we're going to start right now. So we're basically given a function, c of t, and then we're given its derivative. Now, part A asks for the average number of acres affected from t equals 0 to t equals 4. Now, be careful. This is average value. It says average number of acres, not the average rate of change. So we can use the average value formula, which is 1 divided by 4 minus 0, because we're going from t equals 0 to t equals 4, of the integral times the integral 0 to 4 of c of t dt. Now, we can plug this into our calculator. We know that c of t is 7.6 times the arctan of 0.2t, and this yields us 2.778. Now, moving on to part B. Part B asks that we find the time t when the instantaneous rate of change equals the average rate of change from t equals 0 to t equals 4. This is just mean value theorem, right? This is mean value theorem of wearing a fake mustache. Now, we must find the average rate of change first. So the average rate of change from t equals 0 to t equals 4 is c of 4 minus c of 0 divided by 4 minus 0. Remember, we have to set this equal to the instantaneous rate of change because it's find the time t when the instantaneous rate of change of c is equal to the average rate of change. So set this to c prime of t. Now, the left side, after you calculate it, ends up being around 1.282. And this has to equal the derivative, and we have to find the value of t. So 1.282 has to equal 38 divided by 25 plus t squared. And now we have to find t. T, after using our calculator, t is roughly equal to 2.154 weeks. And moving on to part C. Part C asks that we assume that the invasive species continues to spread according to the given model for all times greater than t equals 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species and evaluate this limit expression. So we're given that the rate of change of c is c prime of t is equal to 38 divided by 25 plus t squared. So we have this function right here. Now we have to model this as a limit expression, as the question says. So limit expression always starts with the limit. Right, a little bit better here. Limit as t approaches infinity of c prime of t. Now, after we substitute c prime of t in, this becomes limit as t approaches infinity of 38 divided by 25 plus t squared. Now, how do we evaluate this? Well, we know that as t approaches infinity, t is going to be an extremely large number. Now, what happens when the denominator is an extremely large number? Well, this is going to equal 0. Why? Because the 38 and the 25 are not going to make a difference, because if you take 38 divided by 25 plus, a billion squared or a trillion squared or even a quadrillion squared, the denominator is going to be so much significantly larger than the numerator that it's basically equal to 0. Because if a really small number divided by a really big number, it's going to equal 0. Now, as this approaches infinity, obviously, this will be equal to 0. Now, moving on to part D, the last part here. Part D says that at time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken, and the amount of number of acres affected by the species over from time t equals 4 to t equals 36 is given by this function here. A of t is equal to c of t minus the integral from 4 to t of 0.1 times natural log of x dx. Now we're trying to find the t from t equals 4 to t equals 36, in which a obtains its maximum value. Now, we have to find the maximum value of A, we have to use the candidates test. So how do we do that? Well, we need to first take the derivative of A, which A prime of t is equal to C prime of t minus, and here we can use the fundamental theorem of calculus. So substitute t into t for x here, C prime of t minus 0.1 times the natural log of t. Now we have A prime of t. Now we need to set A prime of t equals to 0. So 0 is equal to C prime of t minus 0.1 times natural log of t. Now, after we put this function in, we get one t value where A prime of t is equal to 0, and that t value is t is roughly equal to 11.442. Now, using the candidates test, we can put, I'm just going to make a little chart here. A of t is equal to C of t minus the integral from 4 to x, for to t of 0.1 times the natural log of x dx. So we put in the two endpoints, which is 4 and 36, and then we put in our t value that we got, where A prime of t is equal to 0, because that is where possibly a maximum or a minimum could occur. Right, this is a critical point. 11.442. Now we basically just substitute these t values in and find the maximum value. So A of 4 is roughly equal to 5.128 after putting that into a calculator. A of 11.442 is roughly equal to 7.317. And A of 36 is roughly equal to 1.743. So from looking at all these values, we see that at t equals 11.442, A of t is the largest, which means that A prime of t is at 0 there, and it's probably it's going to be a maximum, right? Because 7.317 is the largest. So we can say A of t attains its maximum. Now look at the problem carefully. The problem says at what time t. Now we're not looking for the maximum value. We're looking at the time t for which A of t attains its maximum. So the maximum is attained at t equals 11.442. So we can say A attains its maximum at t equals 11.442. And that's it. That's the hardest problem on the 2025 AP Calculus AB FRQ. Thank you for listening. And if you have any suggestions or changes, let me know in the comment section.